Okay, so we've learnt about our area formula for the area of a triangle, a half AB sine C. You've done some examples where you've used two sides and the inclusive angle to work out the area. We're now looking at some examples where we know the area and we're trying to work out one of the elements of that, so a side or an angle. So this example is going to look at how we work out the area of the size of an angle if we know the area and two sides. So with the previous example, if you've got a formula, it doesn't matter if the thing you don't know is the subject, which is on the left hand side, or one of the ingredients on the right. What you can still do is write out the formula and put in what you know, and then you can examine what to do, how to rearrange it from there. So we're going to have a look at this triangle here. We're told that the area is 1.07 square meters. We're given some information about two sides. So we've got 1.5 meters and 2.1. That would mean that we would normally use this angle here at E to work out the area, two sides, and the inclusive angle. And sure enough, it says calculate the size of angle CED. Angle CED is this one here at E. So we're going to find that angle out. I'm going to call that angle X in here for just now, just so that we've got a letter. And if we're using the letters on the angles, the vertices here, C, D, and E, then this side here, opposite angle C, would be small c. The side opposite capital D would be small d. And the side opposite angle E would be small e, just in case we need to use these. Because although the area formula is given as a half AB sine C, you can write it in any letters. So I'm going to write it in terms of angle E means sine E is going to be at the end. So my formula for this triangle would actually look area equals a half times this side here, C and D, side C and D, C, D, and then the sine, or multiplied by the sine of angle E. It doesn't matter if you usually use A and B and C, as long as you're using the correct ingredients, that's what matters. So we'd normally write down all the stuff on the right hand side, because we're normally given that, but in this case we're not. Side C, small c is 1.5, that's good. And small d, side D is 2.1. And the sine of angle E is actually in this case going to be the sine of, well, I've put an X in there, so I'll go ahead and I'll put in X. And capital A is now no longer A, because we know the area is 1.07. So we can put that in on the left hand side. So now, oddly enough, the thing that we don't know is actually way over here on the right hand side. So just like I did with the previous example, what we can do is go ahead and use your calculator to work out all of the multiplications on the right hand side which involve actual numbers. So we've still got here 1.07 on the left, and if I take my calculator and I do a half, 0.5 times 1.5 multiplied by 2.1, just those ones, I get 1.575. So you get 1.5, excuse me a minute, 1.575 multiplied by this thing that we don't know, sine x. Okay, now again we want to get sine x, the thing that we don't know, on its own, and so we would normally do that in algebra. We would normally get rid of anything multiplying by dividing, so we're going to divide through by 1.575 on both sides of the equation. And I'm going to flip it around now and put sine x on the left. So I've got sine x is equal to, they cancel out, that's why there's nothing multiplying by sine x, but on the left hand side I'm going to move that to the right. I've got 1.07 divided by 1.575, 1.07 divided by 1.575, and that gives me 0.6793, 0.679, and that's to 3 decimal places. So this time, because we've got sine x, of course, to get the actual value of x, we have to do the inverse sine. So sine -1 of 0. Oh, my wee button. I have to sort that out. 679. There we go. Do inverse sine on your calculator. Shift sine 0.679 gives us 42.765. So 42. What did I say? 765. So we'll make that 42.8 degrees, and that's to one decimal place. We're asked to calculate the size of angle CED, so I'm just going to finish off by saying angle CED is equal to 42.8 degrees to one decimal place. Okay, so again, if you don't know one of the sides or an angle, and you know the area, you just keep using the same formula, and yet you're going to have to rearrange it at some point to get the value that you don't know. I hope that's helpful. You can practice a little bit more of that on your own.